All right, so this is a problem here out of 8.3, y'all, and we're trying to find the partial fraction decomposition. So the first thing I want to do here is I want to see if I can factor this piece, okay? So the number in front of my x squared is a 1. So if I'm going to factor it, that's the first thing I got to do. And then I'm going to multiply 1 times 18, which is 18. I'm going to make a list of all the numbers that I know multiply to 18. So 1 and 18, 2 and 9, and 3 and 6. So I'm looking for the numbers that multiply to 18, but they need to add up to negative 9. Since they're going to multiply to a positive number, but add up to a negative, I'm going to make every one of those factors negative, because a negative times a negative is in fact a positive. And if I add two negatives together, my answer is still negative. So notice, negative 3 and negative 6 does give me the negative 9. So now, look, we can write this problem so it looks like this. X minus 48 all over x minus 3 and x minus 6, right? Okay, so now this here is the same thing as we have here. All we did is factor out the bottom part. So now let's go ahead and start setting this thing up. So 9x minus 48 over x minus 3 and x minus 6. Since those are linear factors, y'all, my numerators are going to just be real numbers like a and b, okay? All right, so the first step now is we're going to put all of this in brackets, and we're going to multiply it by our common denominator, which is x minus 3 and x minus 6, okay? And I'm going to think of this over 1, but I'm going to take this guy here, and we're going to multiply it here, here, and there. So notice, when we multiply it by this part, this x minus 3 and that x minus 6 are going to cancel with those there. We're just going to be left with a 9x minus 48. When we take this part and multiply it by the second one, the x minus 3 is going to cancel out. I'll be left with a and x minus 6. And when we take this guy and multiply it by the third one, again, the x minus 6 is going to cancel out. We'll be left with b times x minus 3. All right, so now let's go ahead and do some distributing. We have a 9x minus 48 equals, this is an ax minus 6a plus bx minus 3b. Okay, so now we can start setting up some equations. So look, I know that 9x has to be equal to ax plus bx, and negative 48 is equal to negative 6a minus 3b. So from here, I can write out my system. So let me do this on the next slide. We have 9 equals a plus b, and negative 48 equals negative 6a minus 3b. Okay, so suppose I want to use the elimination method. This is supposed to be a plus b, by the way. Okay, if I want to use the elimination method or the addition method, what I'm trying to do here, y'all, is I'm trying to get rid of either the a's or the b's, okay? So suppose I want to get rid of the b's. If you notice, the number in front of this b is a negative 3. The number in front of that b right now is a 1. So if I multiply the top equation by 3, that's 27 equals 3a plus 3b. And if we added straight down, those b's would cancel, right? And negative 6a and 3a would be a negative 3a. And negative 48 and 27 would be a negative 21. So when I divide by negative 3, we come up with a is equal to 7. Okay, so we got a is 7. We can come back to this equation right here. All right, 9 equals a, which is now 7 plus b. And if I subtract 7 on both sides, we get b is equal to 2. All right, so look, we got our value for a, we got our value for b. So I'm going to come back right here. This is the part that I'm looking at. Okay, so I have a over x minus 3 and b over x minus 6. So we're going to say our answer is 7 over x minus 3 plus 2 over x minus 6.